All right, so let's talk about AI subagents. You probably got super excited by the idea, right? This vision of a whole team of AIs building stuff for you, only to get totally bogged down in a slow, confusing, and frankly super expensive mess. Yeah, you are definitely not alone. They promise you this dream team, but often what you get is a bit of a nightmare. Well, today, we're going to untangle all of that. We're going to figure out this paradox and turn that frustration into a workflow that actually, flows. Let's dive in.
I mean, the promise was so seductive, wasn't it? You could just picture it. A main AI, kind of like a project manager, just dishing out tasks to its little team of specialized sub-agents. You've got your front-end agent, your back-end agent, all just humming along, working together perfectly to build these amazing, complex apps. It really felt like we were looking at the future of coding.
And then, reality check. For so many of us who jumped in, the experience was, well, not great. The subagents felt incredibly slow. They were just hemorrhaging tokens like crazy, driving up costs. And the worst part? The final code often wasn't even that good. It just felt like we were doing something fundamentally wrong, like we were missing a huge piece of the puzzle. So what gives? What went wrong here?
Okay, to figure out the fix, we've got to go back to square one and understand the problem these subagents were even created to solve in the first place. And it all boils down to this one really core limitation of LLMs, something called the context window. The easiest way to think about a context window is it's the AI's short-term memory. That's it. It's everything it's currently thinking about, your instructions, its own replies, any files it's looked at. It's all the stuff it can hold in its head at that exact moment. And just like our own short-term memory, when it gets too full, well, things start to get forgotten and stuff just breaks down.
So here's where it gets really sticky. Imagine you have a single AI agent, and you ask it to work on your big project. Just by reading all your files, it could gobble up, say, 80% of its entire memory, its context window, before it's even written a single line of code. So what does it do? It has to start squishing things down, summarizing the conversation to make room. And when it does that, crucial details get lost, and its performance just tanks. This is why subagents were invented. The idea was they could do the heavy lifting, the research, and then just report back a tiny little summary, saving all that precious context window for the main agent to actually do the work.
And this is where we all went wrong. Because the most obvious, the most intuitive way to use these brand new tools was, well, it was the completely wrong way. It turns out pretty much all of us walked right into what I like to call the specialization trap.
So, the natural thing to do was to make specialists, right? You're the front-end agent, you're the back-end agent. Go. But what we accidentally did was create these information silos. The front-end agent does its thing, totally in a bubble, with absolutely no idea what the back-end agent is up to in its completely separate session. It's like they're in different rooms with the doors closed. They just can't see what the other's doing.
And here's why that's such a disaster. The whole system just completely collapses the second something goes wrong. Because each subagent is on its own little island, there's no shared knowledge, no shared brain. And the parent agent, it's completely in the dark. All it gets is a little message that says, task complete. It never saw the code, it has no idea what files were touched. So when you come back and say, hey, this is broken, the parent agent is clueless. It has zero context to help you debug. It is an absolute nightmare.
But what if we've been thinking about this all wrong? What if our whole mental model for how to use them is just broken? Well, after a ton of experimentation, a totally new and way more effective way of thinking started to emerge. And this, right here, is the aha moment. This is the part that changes the whole game. So if they're not supposed to be these siloed little coders, then what are they for? What's their real job? What are they actually good at?
Here it is. They are expert researchers and planners. That's the secret. We need to stop telling them to write code. Instead, we need to treat them like brilliant, tireless researchers and super meticulous planners. Their job isn't to build the house. Their job is to draw up the perfect blueprint so someone else can.
And hey, don't just take my word for it. This insight comes straight from Adam Wolf, an engineer who actually worked on the Claude Code team. He put it perfectly. Subagents work best when they are just looking for information and provide a small amount of summary back. See? Their whole strength is in that research and summary phase, not in actually writing the final product.
Okay, so that's the big idea. The theory is one thing. How do we actually do this? Well, it involves this really clever new workflow. And the key is using something you already have as a kind of shared brain for the whole AI team. Your computer's file system.
And honestly, this new flow is brilliant because it's so simple. Here's how it works. First, the parent agent creates a central file, like a context.md, that just lays out the main goal. Then,
A subagent comes in, reads that file to get the big picture, does all its research on the code base, and then, instead of writing code, it writes a detailed implementation plan to a brand new file. Then it just updates the main context file to say, hey, my plan is ready. And here's the absolute key. The parent agent then reads that plan, and it's the one that executes it and writes all the final code.
So what you end up with is this super clear division of labor. The parent agent becomes the project lead, the executor. It's the one in charge of the final build. And the subagent? It's your trusted researcher and planner. It's doing all that critical upfront legwork to create a perfect, flawless blueprint for the parent to follow.
So, the big question, does this new way of thinking actually work? Is it worth it? Oh, absolutely. And the proof, as they say, is in the pudding, or in this case, the final product.
Get this. Using this exact researcher planner method, the person who figured this out was able to build a nearly pixel-perfect replica of the ChatGPT UI. Think about how complex that is. And the craziest part? They did it efficiently, pretty much in a single shot. No more of those endless, frustrating back and forths trying to debug a confused AI. Just, here's the plan, and here's the clean execution. Done.
So let's just quickly recap the benefits here, because they're huge. First, the parent agent always holds the full context, which makes debugging a breeze. Second, you save a ton of money on tokens because the subagent is just sending back a small plan, not huge chunks of code. And all of that adds up to way more consistent, high-quality code and a success rate that is just, it's night and day compared to that old, frustrating way.
So the big takeaway here is really simple. Stop treating your subagents like coders and start treating them like expert researchers and planners. If you make that one shift, you will unlock their true power. So the only question left for you is, now that you've got a workflow that actually works, what's the first big, complex task you're going to have them plan out?